Good afternoon, periods 4 and 7. So today you will do notes on the distributive property using algebra tiles. So today we're going to learn about the distributive property, and what that is it is defined as the sum of two addends multiplied by a number, and that is the sum of the product of each addend and the number. So I'm going to explain all that I just read to you. So what a simple distributive property looks like is we're going to use A, B, and C as our variables, and our variables could be any number, and whatever those numbers are, we're just going to follow these steps. So we all know that a parenthesis represents multiplication, and when a number or letter is outside of the parenthesis and it's right next to it and there is no operation in between, that operation means multiplication. So if we're starting off with A times B plus C, which is what this statement says, what the distributive property tells me is that I can multiply A times B and multiply A times C, keeping the operation of addition in the middle. So what that looks like is A times B, which is now AB, because they're just numbers, we don't know what they are, and then A times C, adding AC. Or if the A was on the opposite side, same thing. A times B, which would be BA, plus C times A, which would be CA. So now, these are if we would have numbers. Now we can model the distributive property using algebra tiles. And yesterday you noticed that the square tile was 100 tile. We know that or an x squared tile, an x squared. The tens looking tile is a 1x, and the little bitty squares are your ones value. So just recapping that big 100 tile, which looks like this is your x squared tile, positive x squared, because if it's shaded, it's negative. The tens looking tile is just an x, and then your little bitty square like this is just a 1. So if I have 4 of those, it's 4 ones. So let's look at this example here. It tells me to simplify this expression, and so if we would use it in algebra tiles, what that means is that I have 2 represented here times x, 1x plus 4. So what I want to do is I want to multiply that. 1 times that 1 tile, the 1 times the x tile is just x. 1 times the x tile is x. 1 times 1 is 1. 1 times 1 is 1, and so forth. 1 times 1 is 1. So that's how we end up with this answer here. Now what this reads is my answer has 2 x's in it. So I write a 2 and an x because this is 2 x's. My last one has 8 positives. So 8 positives is 8. So my answer is 2 x's and 8, or 2x plus 8. So I'm just going to read this. To set up the geometric representation, place the same number of tiles as the number outside the parenthesis on the top bar, which is what I just did. So this is the number outside the parenthesis. And then place the tiles that represent the expression in the parenthesis on the left of the vertical bar, which is what I did here, the x plus 4. Then to create a geometric figure, multiply the length of the top tiles with the width of the side tiles. So like we did before, 1 times x is x, 1 times x is x, and so forth. Then to write a representation, algebraic, the resulting tile should have the same length of the top tile and the same width of the bottom tile. So that means you shouldn't have anything past this line here, and you shouldn't have anything past this line here. So it should all be lined up perfectly. Then it says to write the representation algebraically, add the like tiles and write the result as an expression. So we're adding the tiles like we did here. 2 positive x's and 8 positive 1, so 2x plus 8. Or if we were to do this with the numbers, like we did up here with the letters, the variables, we would distribute the 2 times the x, which is 2 times x, and the 2 times the 4, which is 2 times 4, keeping the operation in the middle. So we would write this as 2x plus 8. So let's turn on the back and let's do some more work, some more practice. So if I want to simplify 2 times 2x minus 2. So the 2 represents my 2 little ones, and then 2x minus 2. So that's 2 x's. Now, because this is a minus 2, now you could do this 2 ways, because remember I told y'all that the subtraction sign is now negative. It means the same thing. So what you could do is you could go ahead and color in the 2 negative tiles, because that's what they represent, and we'll do it like that first. So we've set up the model. Now we're going to create the geometric figure. So 1 times an x is just an x. 1 times another x is just an x. The same thing here. Now 1 times negative 1 is negative 1. 1 times negative 1 again is negative 1, because we know that a positive times a negative is a positive. So now we're going to add all this together. We have 4 x's. 1, 2, 3, 4. These are x's. And then I have 1, 2, 3, 4 ones. Now these ones are negative. So instead of saying plus a negative 4, I'm just going to write 4x minus 4. And that's my model. So if I was going to convert to algebra form, which is the C, I distribute 2 times 2 x's. 2 times 2 is 4, so this will be 4 x's. Keep the sign in the middle. 2 times 2 is 4, so I keep the signs. Or if you want to read that differently, 2 times negative 2, positive times a negative, is just still a negative, so negative 4. So same thing, so you should get the same answer. So I'm going to leave you to try the next one, but I'm going to set it up for you. You start off with 2 negative x's, and negative is represented by the shaded square. I have a positive x and a positive 1 value. So a negative times a positive will create a negative, and it will be an x, because 1 times x is just x. So it would be a negative x here, and a negative x here. Then we have negative 1 times positive 1 is a negative. Negative. So now I count up what I have. I have 2 negative x's, and I have 2 negative 1s. So negative 2x minus 2. So converting to algebra form, if I was to do this here, negative 2 times x is still negative 2x, plus a negative times a positive is a negative. So instead of putting plus a negative, we're just going to put minus 2, because adding a negative is just like subtracting a whole number. Same thing. Okay, I hope you can do your work on your own from here, and ask each other for help, use each other, and then once you're done with this, you want to work on the assignment 3-9. Okay. So feel free to use it. I would like you to work this assignment using the algebra tiles and the distributive way with just the numbers. All right, good luck.